sum of all the numbers, then sum of every individual digit, all across the numbers, how far we apart we got those two values. One loop to encounter zero tricks, so let's do it. Hello guys, welcome to the channel. I am Rachit Kakkad. In this channel, we crush DSA and competitive programming questions one problem at a time. If you are new to here, smash the subscribe button. It genuinely helps me, and drop a like so we can get the motivation. And today we are going to do is LeetCode question 2535. That's difference between element sum and digit sum in an array, or we can say across an array. Uh, so let's get into it. So you are given a positive integer array, nums. The element sum is the regular sum of all the elements. The digit sum is the sum of every individual digit across every number in the array. We have to return the absolute difference between two. So the example we have is 1, 15, 6, and 3. So element sum would be like, if I explain in simple ways, the how many numbers of element are present in there, you have to just add them. Nothing complex, simple maths. For example, 1 plus 15 plus 6 plus 3, that's equals to 25. That's our element sum. Digit sum is like separating each digit from an element, like 1 separated 1 and then 15 separated 1 and 1 and 5. So we have to do it like 1 plus 1 plus 5 plus 6 plus 3. That's equals to 16. So the absolute difference between the element digit and the sum digit is 25 minus 16. The absolute difference is in the sign. Whichever is there, we have to change it to positive one. So the absolute difference between both of them is 9. Example 2 is 1, comma 2, comma 3, comma 4. Here, the output is 0. You might be wondering why. Uh, because you can see that the element sum and digit sum is same. Element sum is 1 plus 2 plus 3 plus 4, which is equals to 10. And digit sum is 1 plus 2 plus 3 plus 4, which is equals to 10 also. So the absolute difference between the element sum and the digit sum is 10 minus 10, which is equals to 0. One pass through an array for each number, add it to element sum directly, then extract every digit that the number uses modulo 10 and division, adding digit to the digit sum after loop returns the absolute difference. Two sums will simultaneously in a single pass, so no extra memory and no extra loop. So let's walk through the code. We are doing coding in C++ as we are crushing down the DSA. So let's start it. Here we are going to initialize the element sum equal to 0 because initially the sum would be 0. So it would be beneficial for us to add the values in it. As we are going to add the integers only. So digit sum accumulates the individual digits. The digit sum accumulates the individual digit sum and the element sum accumulates the full values of the array. Then we are going to counter the loop here for the calculation of the sum. Here first declaring I as 0. As we are starting the index from 0, then it is going till the num dot size and incrementing the I as well so that it don't stuck at single thing. Calculating the element sum. It is the shortened method to write the element sum. This is the same way we could write it like this is the same way like this, but instead of writing this, we would do a shorthand method. This is the one. For first each iteration, add the full number to the element sum. Then here we are also going to use the shorthand method for the increment one, increasing the number by one, because writing the whole method is Not worth it, right, guys? If you are having the shortcut and then if you are not using it, you are telling that it's foolish things. We copy the current element into a temp variable known as num. Here you can see that the variable int num. Then num mod 10 gives the last digit. Add it to the digit sum, divide 10 to drop that digit. That one is the last one. And repeat until the num hits 0. Every digit of a number gets extracted and summed. And after this, we are going to return the absolute difference of them. You are using the ABS as the absolute difference function. Sorry, that's called a method also. We are going to use that method so our box becomes easy. Return that absolute difference. ABS handle both directions cleanly. First, let's format the code so it looks nice. Here you can see that it is formatted, and let's hit the run button first. So guys, here we have to write that here we have written the digital sum. Here it digit sum. Now I guess there would be no error. Now let's hit the submit button so we can get the surety that our code is perfect. Here you can see that our code got accepted. Also with the pop-up. Let's try run on 1, 15, 6, 3. I is 0. Element sum becomes 1. Digit added. Digit 1 added. Digit sum is 1. Then I is 1. Element sum becomes 16. Digit 5, 10, add 1. Digit 7. Digit sum is 7. I is 2. Element sum becomes 22. Digit 6 is added. Digit 7, sum is 13. I is 3. Element sum becomes 25. Digit 3 added. Digit sum is 16. ABS of 15 minus 25 minus 16. That's completely 9. You have to return 9. And that's correct. The time complexity for this question would be n times d, where n is the number of elements and d is the max number of elements per digit. At most 4, since the number of I goes up to 2000, effectively order of n. Space complexity is order of 1 because just 20 integer variables, nothing else. Worth noting that the digit sum is always less than or equal to the element sum for positive numbers. Any multi-digit number is always greater than the sum of its digit. 15 is greater than 5 plus 1. 99 is greater than 9 plus 9. So ABS is technically always greater. We can say that element sum minus digit sum. But keeping ABS makes the code clean out of clean and safe. And so that's it. The LeetCode question 2535, digit difference between element sum and digit sum of an array. One pass, two counters, classic digit extraction with mode and divide. If this helped you, drop a like, and it seriously means a lot to me. Subscribe so you never miss a video. I will catch up you in the next one. Till then, bye bye, guys.